Today we'll be talking about the creation of lines in order to communicate the idea of depth. First, though, we have a quick little refresher on the basic spatial description systems. And we're dealing primarily with orthographic drawing in terms of sections and plans and elevations. And paralleling drawings are isometrics for now. We'll be dealing with other forms um, upcoming, as well as perspective. But an important idea to kind of get across right now is the one of orthographic projection, and specifically that idea of a picture plane. That there's kind of an imaginary plane, although it could be the paper that an image is somehow kind of projected on, or a form is projected onto it to render the image in a certain way. So with orthographic projection, the object is projected onto the picture plane of the drawing in parallel lines. And so you can measure a drawing of an orthographic and it's true to its actual, there's no spatial distortion, unlike in a perspective system. Now there is projection in a perspective system, and there is a picture plane, which kind of is nicely illustrated here by the 20th century, early 20th century painter Thomas Eakins. But there's distortion in the perspective system because you see that those projection lines come to the point of the eye, and so they're not parallel. Forms in perspective are not projected parallel to each other. They diminish or get larger. So back to paralleling drawings, though, and this diagram of a drawing is in itself an isometric, and so it's a kind of a strange way of looking at the drawing because we're looking at two drawings at once. But there's a kind of a slightly different way of looking at lines in parallel drawings than you do in elevations. So even though the way we're talking about this is in order to communicate depth, the way you treat lines in sections versus elevations versus isometrics are very different. Now, one of the main reasons that you really need to deal with line weight in orthographic drawings, especially in elevations, is that there are cues missing because it's only a two-dimensional drawing. You're only representing two dimensions at once. So there's no indication of depth in those drawings. And you can see that illustrated in the upper left from Francis Ching's great book, Design Drawing, which you can get through the library as an ebook. But that object, which you could read as a house, with two shed roofs, the elevation, or well, you could say it's a top elevation. The top view there shows us that there's two different volumes in that form, but there's no indication of what shape those are. The diagrams in the lower right indicate, you can see that there's two elevations, but all three of those isometrics that are drawn could easily represent those elevations. So there's no indication, at least in those drawings, of what the form of them is, because there's still a lot of information missing. These are a series of drawings that I love, and the reason I talk about them is I think they exploit the idea of line weight, and that these are from an artist, one of the early educators at the Bauhaus, Joseph Albers, who fled Nazi Germany and immigrated to the United States and taught in the Yale Art Department for a very, very long time. But this series of experiments, he's working with the same exact drawings. This is kind of two isometrics of two cubes that are interconnected. And so they're the exact same drawings, but by altering the heaviness of the lines within them, he's creating very, very different spaces for each one. Those spaces aren't clear. They're kind of ambiguous because you could kind of tell maybe what top and bottom is, but where the edges are gets a little fuzzier. But I think it's a really interesting way of looking at the power of line weight. These are the kind of lines we are not dealing with in this class. So we're really primarily interested in depth. This is the American Society of Mechanical Engineers standard line types. So I just wanted to point this out, that depending on the kind of drawing and who you're drawing it for, lines are supposed to mean very, very different things. And the more, at least in the building industry, that the building is actually figured out, that it's resolved, then those lines become very, very codified. So in a set of construction drawings, the building's completely figured out. And so the lines can really be coded and represent specific things. These are not really the lines that we're dealing with in this class. We're working kind of in the design phase, so there's still a lot of unknowns in the project. So the lines don't have to mean so many things specifically. But we're really, really interested, at least in terms of the main thing we're trying to show in orthographic drawings is just spatial depth. And there's three different ways to really achieve this through lines. One is the color of the line, and that's the one you're going to be using the least. That warmer colors tend to advance and cooler colors tend to recede. And that's a perceptual thing. And it might be subtle. It's very subtle, actually. But I suggest it's one of those things that I think you kind of understand if you're at a place with a lot of paintings, like a museum, and you could kind of see that idea at work much more strongly. But in terms of architectural drawings, you're really dealing with the lower two. Pencil drawings are mostly about tone. Lighter toned lines appear distant, um, or shallow, that there's not a lot of depth to them. And harder pencil leads, because they have more clay in them as opposed to graphite, will kind of have a lighter color. You know, your 4H will be a much lighter color than your 2B, even if they're sharpened to the same exact thickness. So tone tends to be the domain of pencils, although there's always a little thickness in there as well. Thickness is what pens do the best, because if you have a set of drawing pens, those have numbers on them or some designation that you understand exactly the kind of line weight you have. Whereas with pencil, it could be a little more difficult, because you're dealing with the tone of the line, the lead you're drawing with, as well as how thick that pencil line is. You don't want to try to draw heavy lines with a dull pencil. You're trying to at least build up 2 or 3 lines in order to get that slight thickness, but you really want to try to depend more on tone than how heavy or thick a line is. And by the way, that's the reason why at the beginning of this presentation that I call this the hierarchy of lines, and not necessarily line weight. Although generically, when we talk about line weight, we mean the hierarchy of lines. Line weight tends to be really about how thick something is, not necessarily how heavy its tone is. So I just kind of talk about this as a hierarchy of lines, as just a way to kind of reframe your reference of how to think about this. But for the most part, when you're creating a drawing in elevation and the spatial parts of a section, the density of your line, whether that's thickness or tone, is really determined by the distance to the hypothetical picture plane. Forms that are closer to this picture plane, and you can also think about it as the viewer, forms that are closer to you will have the denser lines. So it's easy as that. And in this diagram, you can see there's a pyramid, a cube, and a polygonal form. And the cube being the closest thing is the darkest. So there's an idea of kind of distance. That pyramid's way in the distance. So even though it stays the same height, it doesn't get smaller as it gets away from you. It does get lighter in line weight. And it could be the idea that maybe even if it was farther away, you draw it in an even thinner line, or an even lighter line. Just an example of kind of a basic form and what it looks like in elevation. I am showing you the isometric of this form, so you have an idea of what it looks like. And there's a little bit of line weight going on in there, but I see there's already 2 wrong lines in that drawing, so I'll show you the corrected version in a minute. But the lower elevations are what I'm concerned about, and you can see how those planes of this form that are closer to you are the ones that are the darkest. Just another form, and in this case, you can see how the shapes that are closest to you, the planes that are closest to you, are the darkest, depending on what elevation you're looking at. I throw this slide in as well just to show there are other ways to think about this. I won't get in those today, but there's always a way to kind of push this a little further. And again, it depends on the drawing you're doing and what it is. But there's a way to draw these things that you're emphasizing edges instead of planes, and it has to do with how deep that edge is. But for the most part, 90% of the time, we're really worried or concerned with how close a plane is toward you, the viewer, the picture plane, and that's what designates it. That's why you draw it with a darker line weight. Sections are a slightly different animal. For the most part, all the rules are the same. The closer something is to you, the darker it is. With the major exception is that the profile, the line that's cut through that, is always the highest intensity. It's always the heaviest. It's always the darkest. No matter what else is going on in the drawing, the section cut of your line is always the heaviest. And the how you deal with the poche, the area of, the pocket of space inside that, is, well, actually the other common hour lecture is going to deal with that, but it really depends on, again, what you're trying to do. But there can be a lot of different ways of dealing with it. A lot of times you just see it rendered as being solid black, and you can see there's three sections on the bottom left of this form. And I actually have those three. I would say the gray one works the best. Although again, it depends on the drawing. Also, I did throw in section flags here, although usually you only see those in a top view. I included them here in the elevation views because those and the isometric, just so you can better visualize what's happening in the section. Another great drawing from Francis Ching, that I think really illustrates the idea of how a section is just this thin slice that's taken out of a building, and how that by coloring the poche a certain way, it emphasizes certain parts of it. And I always like to kind of point out the little beams in this house and how those come to that section plane and they're cut through. And so you see that a lot of times in a section you will see little forms, that are pocheed, that are being cut through, and a lot of times that's the structure of a building. This is one of my favorite drawings, and one of the reasons I like to talk about it in the context of poche is that there's no poche in this drawing. So this is a situation where, just an incredibly technical, beautifully technical, difficult building section through a building in the 19th century, and this is an ink wash, and this section, you can see the kind of profile line and how it's kind of cutting through the niches. So you really have a good idea of what that section line actually does. But the poche is empty because there's shadows inside this drawing. There's a lot of depth being connotated in this drawing. So depth is already exists, so there doesn't need to be really any line weight. And because there's so much detail inside of this drawing, the section, if there was an attempt to poche the section, it would just make it too busy. So in this case, the poche is left alone. Here's a more contemporary version, at least from 40 years ago, which is kind of a really strange condition that this house was built in, because there were there were other buildings around it which kind of encroached on its territory. So there's kind of large areas of masonry being cut through. But it's another drawing where the poche is left blank, because the spaces themselves are drawn or rendered very well realistically in terms of shade and shadows. So in terms of plan, and remember that plan is just a horizontal section. But one of the important things to just remember is when you're cutting through something like a window, and by the way, in this little diagram, I haven't included glass in these windows, so glass or windows or doors. So you could just consider all of these things openings. But you see how the line weight in plan of the wall gets lighter when it crosses through those openings, because there's nothing being cut through. I left the poche blank here. But I think it's just easy to understand how that becomes a really important idea in order to communicate what is and what isn't being cut through. Also notice how the thickness of the wall is shown as 2 lines, even where there's a little bump and there's kind of a thin line that could be some kind of closet or something. but there's no seams shown within the poche, even though there's kind of different walls going on, especially around the doorway. Everything's kind of shown as one continuous surface that you're being cut through. All right, the most important slide of this whole lecture, and the second to last one, and I think actually the clearest as well. And that's how to do line weight within parallel drawings. Specifically, we've been dealing with isometrics, and so it goes from darkest, I'm sorry, darkest to lightest, and the darkest is the spatial edge. And I know this term might have been used before in elevations, and it kind of meant something slightly different, but it's very kind of specific here that in an isometric, a line that doesn't show both sides of the edge. If you don't see both faces that make that edge, you could consider it a spatial edge. So you see there in the object to the left, there's an overhang. So, and you only see one edge of what's making that line that is the overhead. So that's your darkest line. And the line that surrounds the whole object is darkest as well. So that's the spatial edge, and that becomes the real important designation within three-dimensional views. That spatial edge is really what makes things pop out and make them seem spatial. So your spatial edge is your darkest, and then your kind of middle line weight is the outer corner. And that's basically something that's pushing an edge that's pushing towards you, the viewer or the picture plane. And then there's an inner quarter, which is an edge that's pushing away from you, that you see both faces of you, but it's receding away from the picture plane. I have to point out here, though, we're drawing these objects as if they're floating in space. So that dark spatial edge goes around the entire thing. If we took this object and put it on the ground line at the very bottom, there's 2, 4, 6 lines there where that object would be hitting, the ground would now become all inner corners, and they would become the lightest. So just one of those things when you start actually drawing buildings in context, things will get slightly different. But for now, we're treating these as objects that are floating in space. So you're going to do a dark profile around the entire corner. So there are always exceptions and variations to this. You will start finding maybe your own way that you like to do certain things, or there's a certain logic to it that starts to happen. I think one of the reasons why you really won't see a lot of detailed explanations of why things should have a certain line weight to them or not is just because it varies so much from person to person. So it's one of those where I really strongly suggest you start to develop your own ideas and techniques about that. But I think about line weight, I think the important thing, however, is that you try to be consistent within whatever drawing you're working on, and that it's that consistency that kind of creates the language of the drawing. And sometimes it's only even within that drawing, but it becomes a very important idea or a very important concept on how to really kind of take your drawings to the next level when you have an understanding of how you want to use line weight within that drawing. All right. Thanks.